What's going on, everybody? This is Mr. Diamond, and today we're going to be talking about molecular or covalent compounds. Now, you have probably noticed that I use those two terms interchangeably, and they're both correct. They are completely interchangeable. Covalent describes the bond. They are covalently bonded together compounds, and we call covalently bonded compounds molecules. So molecular or covalent compounds are the correct names. These compounds are held together with covalent bonds that share electrons. Remember, covalent are co-owners of valent electrons instead of ionic that are stealing them. And these compounds are made up of two or more nonmetals. For the purpose of this class, they are only going to be made out of two of them. Their formula represents one molecule of the substance, a molecular formula. So they show the actual number and kinds of atoms, meaning they are never, ever, ever, ever reduced. If you know you're dealing with a molecular compound, you do not reduce it. So like in the example we worked in class together, we talked about how, as I glance over to try to remember what it was, if you crossed the charges of lead 2 and oxide, you would have gone Pb has a negative 2 or positive 2, oxide has a negative 2, cross them, you would get Pb2O2. But then we said that last step was you had to reduce it because ionic compounds are just ratios, they're just clumped together. Molecules and molecular compounds are not. When you say water is H2O, that doesn't mean that there's just two hydrogens and one oxygen kind of together. That means that there is an oxygen bonded to two hydrogens. They are connected by covalent bonds, by those little lines when we drew our pictures. So because they're connected in that way, you don't reduce them. That's why we can have things like glucose that are C6H12O6, and you could reduce that by 6, but we wouldn't because it's a molecule. And glucose is actually C6H12O6. It's not a 1 to 2 to 1 ratio. So molecular compounds have their own set of rate naming rules. We only use them for molecular compounds, and then we're only going to be naming binary molecular compounds. So like I said, there are other ones like glucose that are made out of 3 nonmetals, but we're only going to stick with ones that are made out of 2. And to do them, you need to know these prefixes. Now, you're probably like, Diamond, you just told us we had to memorize like 14 polyatomics. Why are you also making us memorize a bunch of prefixes? Most of these prefixes should make a lot of sense just from kind of popping up in your day-to-day life. Mono means 1, di means 2, tri means 3. That's pretty logical. Tetra means 4. That's usually a weird one for people, but if you remember when we talked about tetrahedral geometry, I said it made a 4-sided shape. So tetra means 4. Then penta is 5, hexa is 6, hepta, most people want to do this with an S, but it's with an H. Hepta is 7, octa is 8, nona is 9, not a grandma, nana is 9, and then deca is 10. Nana is like the Italian, one of the Italian ways that people talk about their grandmas. Just, if you don't know, well, I didn't just like say a completely unrelated thing right there. And then deca is 10, which is where we get the term decade, actually. So for naming molecular compounds, you first check the first piece. Remember last time we checked if it was a metal or a nonmetal. If it was a metal, if it's an ionic compound. If it's a nonmetal that isn't hydrogen, I'm actually going to go ahead and like really quick edit this together. We're going to go molecular compound is a nonmetal that isn't hydrogen, other than hydrogen. Oh, man, now it's going to look ugly. This is the life we lead. We're going to do this. And then we're going to do this. Then we're going to do this. And then we're going to do this. Okay, so for a molecular compound, the first thing has to be a nonmetal other than hydrogen. If it's hydrogen, then you're going to be dealing with what's called an acid, and we'll get to that in a little bit. And then the second piece would also therefore be a nonmetal. For the first nonmetal, you name it using the prefixes, except for mono. So if there's only one of the first thing, you don't actually have to say mono. If it was just like, let's say O and then into, you would not say monooxide or monoxide. You would say just oxide. It's the first thing, so we assume that if there's no prefix, there's nothing, it's just one of them. There's no extras attached to it. For the second thing, and it technically wouldn't even be oxide because you keep the element the same. It would have been oxygen, so it'd be monoxygen, which would have been even weirder, but dioxygen at least kind of sounds a little bit cleaner. And in the second nonmetal, you always use a prefix, and you change the ending just like before to IDE. Again, that lets you know something's negative, but in this case, it's more important for the fact that it's letting you know it's attached to something. It goes to the thing that it's right after. We're going to do a couple of examples on the video that's attached to this in the notes. That is, again, as you've probably noticed, these notes are really short. That's the notes for molecular compounds. All we've got left is just some examples. Again, I'm not necessarily going to use the ones from this list because I want you to be able to go through and do these as extra practice problems later when I post the PowerPoint. So in the meantime, if you have any questions, please let me know. Otherwise, this is Mr. Diamond signing off. I hope you have a good rest of your day, everybody.